The objective is the same, the problems are a little different. So we're going to solve exponential equations in just a little bit different way than we did yesterday. Here's the first example. 64 to the x minus 1 power, and then you'll have 4 to the 6x plus 8 power. Here's just somewhat of a review from yesterday. You have 64 and 4 for the bases. Luckily, 64 is a power of 4. So we can rewrite the 64 as 4 to the third power and then raised to the x minus 1 power, and keep the right side the same. So then we can distribute the 3 exponent to the x minus 1 exponent and come up with 4 to the 3x minus 3 power equals 4 to the 6x plus 8 power. And from there it's just basic equations. So it's going to be 3x minus 3 equals 6x plus 8. And of course you'll have 3x minus 6x and 8 plus 3, which is going to be a negative 3x equals 11. And it comes out to be a fraction. Negative 11 over 3, or negative 3 2/3. Or negative 3.67 if you round to the hundredths place. Alright, 32 and 2. How can I change those bases into the same number, and what number is that? 2 to the 8th power is 32? 2 to the 5th. Alright, so 2 to the 5th power, and then x minus 5. And then over here 2 to the x plus 3. So distribute the exponent of 5 here to this, and come up with 2 to the 5x minus 25 equals 2 to the x plus 3. Of course, once you have the same base, you can do 5x minus 25 equals x plus 3. And just solve this equation. 5x minus x, 3 plus 25. 4x equals 28 actually comes out even. You just end up with 7. $12 and 144, what's the new base going to have to be? It's going to be 12. So there's nothing to do to this side. And what would you do to 144? 12 squared and 2x plus 1. Alright, so simplify the right side. And 2 times 2x plus 1 is going to be 4x plus 2. Alright, so 3x minus 2 equals 4x plus 2. And solve this simple equation. 3x minus 4x, 2 plus 2. That's a negative x equals 4. So you'll come out with x equals negative 4. Alright, 8 and 32. We can't change 32 to a base of 8, and we're not going to change 8 to a base of 32, but we can use another number, some number to a power that would be 8, and then in another case would be 32. That number is 2, and 2 to the third is 8. On the right hand side, 2 to the 5th is 32. So simplify your exponents to come up with 2 to the 6x plus 6 power, and then on the other side 2 to the 5x minus 25 power. Once you make it to that point, you can set 6x plus 6 equal to 5x minus 25, and come up with 6x minus 5x equals negative 25 minus 6. So x would be a negative 31. You have 9 and 27. Don't make the mistake of thinking I can multiply 9 by 3 and get 27. That's not how you're going to change the base. You have to reformulate these with bases to some exponent, some power, such that they will have the same base. Multiplying this by 3 isn't going to help you out. And you can't do anything to 9 to get to 27, or vice versa. So what you have to do is think of the other number that you can raise to a power that's going to give you 9, and then another power to get 27. That's going to be 3. So 3 squared to the 4x minus 6 power equals 3 to the third to the 2x plus 5 power. So that's going to be 3 to the 8x minus 12 power equals 3 to the 6x plus 15 power. Once you reach that point, you can set these exponents equal to each other. 8x minus 12 equals 6x plus 15. And 8x minus 6x equals 15 plus 12. 2x equals 27. So 27 over 2 is the right answer, or 13.5. Four and 8, we can't use either one of those, but we can use 2. 4 is 2 to the second power, and 8 is 2 to the third power. So that gives us 2 to the 2x power equals 2 to the 6x minus 12 power. And we can set 2x equal to 6x minus 12. 2x minus 6x equals negative 12. Negative 4x equals negative 12. And obviously x would be 3. We can change the 16 and 64 to a 4 and come up with 4 squared to the 2x power equals 4 to the third power to the x minus 4 power. So that's 4 to the 4x power equals 4 to the 3x minus 12 power. Therefore, we can do 4x equals 3x minus 12. That gives us 4x minus 3x equals negative 12. X equals negative 12.